Okay, let's get started. Welcome to today's webinar in our series on the future of AI in education and training. I am Lewis Johnson, the overall host of the webinar series. Let me quickly share my screen here. So a little background on me. I done a lot of work in research in AI in education, and also I'm CEO of a company that, Alelo, that uses AI in promoting learning. So the reason why we organize these series of webinars is that we see artificial intelligence being adopted in many sectors of the economy, and that includes the education sector. And we believe that AI can have a big impact on education and training. And in these webinars, we're exploring just what that impact may be. And there's a lot of uncertainty. People have questions about what the impact of AI is going to be in this area. What will happen to learning? How will learning change when every learner has access to their own personalized AI-driven learning tools? And how will teaching change? Will robots replace teachers, or will AI empower teachers and help them teach more effectively? We're exploring these questions in the context of this series. And today's speaker, Ran Liu from Mari, is going to be talking about a new type of learning tool that AI makes possible called intelligent mentoring systems. And these are designed to support learners not in individual academic subjects, but throughout their learning journey to promote long-term success. And these have potential to help develop a workforce that is prepared for the 21st century workplace, for the skills that are needed in this new workplace where people are working alongside and with AI on a regular basis. So Ran, thank you for joining us. We look forward to your presentation.
Great. Thanks for the introduction, Lewis. I will just switch it over to my screen. And thanks everyone for joining the webinar, talking about intelligent mentoring systems, as Lewis mentioned. So I'm just going to start by giving a quick background of my own training. So I did my PhD work at Carnegie Mellon University, specializing in cognitive learning sciences with a focus on language learning. And then in my postdoctoral research, I worked with Ken Kiedinger and John Stamper. And they are—
Ron, you're a little hard to hear, but if you could maybe speak up or adjust your microphone.
Okay. Can you hear me better now?
I can hear you a bit better now.
Okay. Sorry about that. Okay, so my postdoctoral research with Ken Kiedinger and John Stamper focused on data-driven skill model discovery within the math domain. We also ran a variety of studies looking at the actual educational outcomes that resulted from data-driven technology improvements that were implemented in the classroom. And in addition, I worked on a variety of projects looking at multimodal data analytics, and I'll be talking a little bit more about that later as it relates to 21st century skills. I also wanted to give a quick shout out to Montour School District, which I worked very closely with in my postdoc. And in particular, they're a school that I think is really embracing the rapidly changing economy and emphasizing 21st century skill learning in their curriculum. And I just think they're doing a great job at that and serve as a model school for other schools to follow suit. And they have also inspired me to become more interested in this area. So now I work at Mari, which is a startup, and we are a tech platform supporting personalized lifelong learning and guidance. And in the K-12 space, we've mostly worked on career-aligned goal setting. Once the goal is set, we kind of work on identifying skill gaps between the individual and the goal and closing those skill gaps. And at Mari, I work on both developing and maintaining the intelligent data architecture as well as whole person skill analytics. All right, so I'm going to start off with a question that I'll throw out there. What's the purpose of education? And in a book recently published by Tony Wagner and Ted Dintersmith called Most Likely to Succeed, Preparing Our Kids for the Innovation Era, they make the argument that the purpose is to engage students with their passions and their sense of purpose, to teach them critical skills needed for a career and citizenship, and to inspire them to do their very best to make their world a better place. And I wholeheartedly agree with them. So with that context, I think particularly with respect to preparing our students for the workforce, K-12 schools could not only do a better job on academic skills such as writing, mathematics, reading comprehension, but also 21st century skills, many of which are critical to today's job market. And not only that, but they're not really specifically being taught in most K-12 schools. And as you can see, employers have rated a lot of these 21st century skills as being deficient in new hires who are coming with just a high school diploma. So I think this is indicative of the need for better alignment of the skills that we're teaching our kids in school to the actual skills needed in today's evolving job market. So I think that this is actually more important than ever because our workforce is changing ever rapidly. And a lot of this is due to the rise of automation with emerging technologies like AI. Many experts believe that a significant percentage of jobs are now at risk of being automated out. Or, at the very least, that the responsibilities and skills required for those exact jobs are going to be changing as the result of automation. So clearly, we really need to evolve our educational landscape to target the skills that are going to allow students who are coming out of our K-12 education system to be able to adapt and continue to keep up with the changing 21st century workforce. So fortunately, there are a lot of initiatives going on at a subset of schools around the country. And they've been beginning to shift the focus towards fostering these 21st century skill sets. In this particular talk, I'm going to explore the role that AI and technology more broadly can play in solving this problem. So most intelligent systems in education, as well as education technology that's on the market, focus on tutoring really specific academic subjects, and they deliver personalized learning on a relatively short time scale. So I'm going to talk a little bit about the unique challenges presented by an implementation of personalized learning that has ultimate longer-term goals of preparing kids for career competencies, or even midterm goals of just preparing our students to graduate high school with the relevant sort of 21st century skill sets that are needed in the job market. So I'm going to talk about some of the promising approaches and frameworks as well as resources that can help us address these unique challenges. That said, there's two approaches I'm going to kind of organize the talk into today. So the first approach, mastery-based personalized learning, is largely based on this exact approach that has been used in AI and education for specific academic subjects. And I'm going to be talking about how to adapt that to 21st century relevant academic and meta-academic skill sets. And then in the second part of the talk, I'm going to discuss some modeling approaches that I believe will be helpful for learning things like, so for learning pathway sequencing advice and addressing more of the sort of temporal sequencing recommendation aspect of intelligent mentorship. All right, so mastery-based personalized learning is the approach that has been traditionally used by intelligent tutoring systems and cognitive tutors, as well as by popular education technologies like Khan Academy. And it works pretty well as an overarching framework for personalized learning. And the way that mastery-based personalized learning works is that first you want to identify and define the skills for which you want to achieve mastery on in order to attain a goal. So this could be, pass my Algebra 1 standardized exam, or it could be something like I want to, achieve financial literacy by the time I graduate high school. So the second thing is to then use all the data that you have and collect all the measurements you need and additional data that you need to be able to model and estimate the learner's level of mastery in each of those target skills. And then finally, we want to help the individual close those skill gaps by recommending to them additional practice on the skills that they have not yet mastered. Okay. So this has worked really well in academic settings for things like intelligent tutoring systems. There are some unique challenges that are introduced to applying such an approach to something like a 21st century skill set, and I'm going to talk a little bit about those as well as how we can address some of those. So the first part, identifying and defining the skills for which mastery is desired in order to attain a goal, is actually kind of a difficult problem because although academic skill frameworks, such as ones for Algebra 1 or geometry, are very well defined typically, the kinds of more 21st century or what we might call, quote, soft skill sets are a little bit more elusive, and there are not as many frameworks to concretely define those. So I am going to just outline a few resources that can be used to start to create some of these rich skill profiles that are relevant for careers as well as general skill sets that will help one navigate the job landscape in the 21st century. So this is ONET, which stands for Occupational Information Network, and it's basically a free online database that contains hundreds of occupational definitions that are specified all the way down to specific skills. So you can kind of see that I am navigating to the skill set for a marine engineer and breaks it down into technical skills and tasks and knowledge and skills. So this is a great database that can provide a starting point for identifying some of the skills that are important for a specific, career pathway or a specific type of occupation. And you can see under the skills, things like critical thinking, active listening, reading comprehension. We see these kinds of 21st century skills show up job after job. So these are very general skill sets that are needed for most of the jobs. Right? And in addition to that, we can actually leverage real-time, current job posts on places like Monster or LinkedIn, and we can mine the text of the job post to extract the kinds of skills that the job post seems to be implying that are required. So, for example, here we might extract skills like advertising, creative social media, market research, content creation, and PR. So this might get extracted in a way that's based on the preceding and following language context that tends to statistically frame the referencing of specific skills. So, phrases such as in the areas of or using tools such as, these are very common phrases that precede the listing of actual skills. So we can use some of these natural language techniques to pull out skills from job postings and create profiles that way. And then at Mari, we actually also created a tool that allows real employers to build deep, well-defined skill profiles, and they can actually pull in skills that we have in our database and use those to construct these profiles. And that eases the burden of us then matching those skills up to data that we may have collected for those particular skills on students. All right, so then moving from career competency profiles to 21st century profiles, there is an organization called Partnership for 21st Century Learning, and they have put together a really nice framework for 21st century learning that contains a skill breakdown of things like critical thinking, computational thinking, collaboration, etc. So they're a really good resource to use in order to get frameworks for these more general 21st century competencies. And then similarly to the Partnership for 21st Learning, a variety of other major players working in this area have also developed what they consider to be the foundational skills for this century. So you can see that a lot of these skills overlap, things like critical thinking, problem solving, the ability to cooperate, manage and resolve conflicts. These are things that come up over and over in lots of different groups. So clearly we know that those are important skills for us to be focusing on identifying and defining and measuring. And in addition, many states have begun to adopt 21st century skill sets as part of their graduation requirements. So Virginia is an example of this. They have a graduation requirement called Profile of a Virginia Graduate, and it contains a variety of these 21st century skills that they've selected in particular. So we can actually make use of these guidelines and create skill profiles for high school graduates in the schools that we work with to start to link their data up to these profiles. All right. So once we've identified what the skills are that we really need to be matching students up to, then the challenge is really to kind of map the existing data that we have up to those skills, as well as to figure out ways to measure those skills so that we know where an individual stands with respect to all the skills required for a particular profile. I'm going to start by talking about some ways we can measure these. All right, so there are actually many different research-validated assessments out there, even for these so-called soft skills. So, for example, there was a handbook on measuring 21st century skills published last December, and in it, researchers break down skills into 4 categories: creativity, critical thinking, empathy, and executive function. And what they do is they then break each of these categories down into sub-skills and went out and searched for research-validated assessments for each of these sub-skills. So I'm showing you the category for creativity right now. And so this is the breakdown for creativity, and on the left panel are sub-skills of creativity that they believe there are well research-validated measures of, and those measures are listed. And then on the right are sub-skills of creativity that they do not believe there yet exist research-validated measures of, although I think in some domain-specific contexts there are measures of some of those skills. As an example, another example, this is the breakdown for critical thinking, a lot more sub-skills on this one. And one thing that's really striking is the quantity of sub-skills that there are to consider, even in a relatively constrained broader skills such as critical thinking. So to reliably assess all of these sub-skills would require a lot of time, and kids already spend enough time doing assessments in the classroom. So, and in addition to that, there's always concerns about ecological validity of survey-based assessments. And so with advances in technology and learning analytics, there are beginning to emerge potentially better and more naturalistic ways of measuring some of these qualities. Much of this work is captured in the field of multimodal learning analytics. And this field is particularly concerned with using measurements from lots of different modalities. So collecting data from different modalities to gather rich information about learning as it unfolds kind of in the natural context, whether that's a classroom or a museum. And some of the kinds of modalities that are common to collect in this field of research are audio, movement, which you can do with a Kinect, video of the classroom, or even webcam video of the individual. You can collect data on what the student is writing or diagramming or drawing using a digital pen. And there's even starting to emerge some data collection with Fitbits. So in this field of work, the challenges of being able to make sense of all of these multiple modes of data that are being collected begin with what we call feature extraction. So all this data is collected and coming in with just raw signal. So I'm just going to give you an example with audio. When audio comes in, it's just like a bunch of waves, and we have to go from all of that sort of raw raw signal to turn that into meaningful features that can tell us then about, how good is a student at understanding the concepts that they're explaining to their partner, for example. So there's a lot involved there. And so the first step is even just processing the audio and parsing it into the words that were spoken by the individual in that audio. And that's a whole process that sometimes is done by a human, but sometimes is done using automated methods. But if any of you have used Siri and had it, translate what you wanted it to get incorrectly, you know that this is still an imperfect process. But technology is starting to get to the point where we can relieve some of the burden on human transcription. So once we've got it transcribed into words, then we've got, the challenge of figuring out, okay, well, what does this piece of dialogue mean in terms of the student's ability in this dimension, or their conceptual understanding, or the procedural skill ability, things like that. And so we then have to take those words and further use natural language processing tools to aggregate them and understand more abstract features from them. And so some of these features might include function word types and sentence linking connectives and respect words, things like that. So these are some features that have been identified in this particular study to relate to outcomes. Similarly, there's software that can extract things like, presenter's gaze from eyes and nose tip low-level feature-based information. There's software that can process connect data and classify them into common postures. So then what happens is that these extracted features will be modeled in terms of how they predict human-coded categories of behavior, such as different levels of eye contact, as well as body and posture language categories. So in a recent study that was looking at students' presentation skills, they actually tried doing this automated feature extraction and then category prediction, and they only achieved about 50% accuracy. So there's a lot of work left to be done to get the automated ways of doing things like this as good as a human coder. So, but I do think that the fact that some of these technologies are developing rapidly means that, potentially in the near future, we will be able to do this with very little human labeling or human effort, which is promising. All right, so okay, so I've shown you a couple of different types of ways that we can start to measure these more soft skills or 21st century skills. But in addition to that, there's actually tons of data that's sort of passively being collected by most school districts that we can bring to bear to better understand some of these 21st century skills and where kids stand along these skills. So, these include sources like student information systems, teacher observations, credentials, and standardized assessments, as well as a variety of commercial education technologies that students are beginning to use in the classroom. So the big challenge here is, once we have and gather all of this data from all these different sources where they already exist, how do we map that data properly to the skills that are actually part of the goal profiles that someone cares about? So in this example, the student has set the Carpentry 1 competency as his or her goal profile. And what we can do is start to fill in our estimates of some of the skills that we already have collected data on through the school. So for example, there's a whole mathematics category of Carpentry 1, and there's a lot of data from their working towards completing their standards of learning to bring to bear on that. So this particular example, the skill, as we have data associated with it, the skill is called create and solve single-step and multi-step practical problems involving addition, subtraction, multiplication, and division of whole numbers. So we have, let's say a pretty strong mastery estimate for that skill. But what the student really cares about is, how am I doing with respect to my applied carpentry mathematics? And the way that the particular matching skill is labeled in that competency profile is add, subtract, multiply, and divide whole numbers with and without a calculator. And so you can see that the wording is slightly different. And this is actually one of the simplest kinds of examples of mapping that we have to deal with. So you can imagine that this is a problem that we have to work with over and over to be able to connect data right up to the skills that are relevant in terms of the student's goals. So we have to do this for not just academic data, but a huge variety of non-academic data. For example, attendance and discipline data, volunteer hours, extracurricular activities, and other skills associated with non-academic credentials or badges that a school might award. We have to kind of make sense of that and say, what does this tell us, if anything, about the students' skills that are relevant for the competencies they're interested in. So, so this is a big mapping challenge, and again, we use a lot of natural language processing techniques to help us achieve this and to ease the burden on a human having to manually do this mapping. But that said, our last line of defense in these cases is almost always a human at least verifying that that mapping makes sense, and then we can use those human labels as what we call ground truth labels to make sure that our models continually get refined and updated to be able to do this better in an automated way. So another piece of this challenge of storing and mapping all of this data is, how can we make the process of storing it easier, and how can that, method of storing it and ingesting it be standardized in some way? We're a fan of data interoperability frameworks, and in particular, there's a framework sponsored by the Department of Ed called Common Education Data Standards, and it's a very good framework for thinking about K through career, because as you can see, they've really broken down the data in a lifelong fashion. So if you look at all these different domains that they cover, it goes all the way from early learning to K-12, all the way through adult education and the workforce and career and technical education. So they've really thought about a longitudinal data store, and that's hugely beneficial when you're trying to do something like start in K-12 and aim for a career and lifelong learning. So they, as part of this framework, they've provided a common vocabulary, and they've also provided data models to organize that vocabulary. And so, yeah, we found this framework to be extremely helpful. And they've also been aligning with a few other interoperability frameworks. One of them in particular is the EdFi Alliance, which not only provides a data storage framework, but they also provide an API that works with lots of education technology vendors, and in particular, a really big one, which is PowerSchool. That's a really helpful thing to be able to start to integrate data without needing a human to manually map all of that data. Another framework similar to EdFi's IMS Global. And then there's also a framework called XAPI, which stands for Experience API, which is an e-learning software specification that grew out of SCORM, which was a US DoD research-sponsored initiative. And they're also an interoperability framework for being able to track lots of different types of activities throughout one's lifetime that might relate to learning. All right, so finally then, the biggest challenge once we figure out the skill gaps is being able to recommend a resource for any particular skill that a student might have a gap on. So there's starting to become more resources available for this, especially for non-academic, more 21st century skills. So I just wanted to mention, though, that Khan Academy, they do provide really great resources, especially for skill gaps in the academic domain. One great thing about Khan Academy is that you can deep link to really specific groups of exercises, so that someone can only work on the kinds of topics that they really have skill gaps for without having to go through an entire curriculum, much of which they may already know. Khan Academy also goes beyond academic things to provide things like SAT prep and financial literacy and business-related prep. So they're a great resource. And so the partnership of for 21st century learning has also recommended a variety of non-technical resources that schools can implement, and those are specifically focused on 21st century skills. And nowadays, there's lots of massive open online courses that have popped up, specifically targeting soft skills or 21st century skills. So, you know, Coursera has offered them, study.com has offered them, so there's a lot, and you can usually find them just through Google or through word of mouth. And then I also just wanted to mention that there's also companies like Alelo who are creating educational technology programs that specifically do target career or job relevant skills. And so as you can see on the left here is one of their programs that is working to train the employee on communication style, with this interactive agent, which is really great. And then on the right, you can see another one of their products, which teaches culturally sensitive or culturally specific dialogue. So these are all really great resources. And there are many other resources like these out there. Again, the biggest goal is, you know, once we can link to these resources from the proper skills that they would help address, or close gaps for, we want to then be able to understand, you know, how the learner did with those resources and what it means now that they've completed them in terms of their improvements on those particular skill gaps. So that's, again, another mapping challenge that we're working on, and, you know, and just being able to identify what all those resources are out there in the world for all of these soft skills is something that we're actively working on as well. All right, so now I'm going to talk a little bit about a slightly different flavor of approaching intelligent mentorship. It's a little more focused on the issue of, well, I know what skills I'm lacking in, and I know some resources I can use, but what's the most useful thing for me, just in a broad career picture way, for me to do next? What should my next best decision be if, you know, my goal is X? So I'm going to talk about two modeling approaches that I've thought about for this problem. You know, this is not something that has been extensively explored in the literature yet. I think it's because it really requires a really large and diverse amount of longitudinal data to be able to train up these kinds of models. But these are just some ideas. So one approach could be similar to what I call the, quote, Netflix recommendation model. And the idea here is, you know, the way that Netflix recommends you movies is it looks at other people who like the same kinds of movies that you do and dislike the same kinds of movies that you dislike. And they use many other features as well, but, you know, just to give you an oversimplified conceptual idea, that's roughly what they look for. So they look for clusters of people who are similar to you in terms of the, you know, let's say thumbs up or thumbs down pattern across a variety of movies. So in the similar way, we can think of an intelligent pathway model as we can cluster you with other individuals who have, at some point in their careers, right, a snapshot of their mastered and unmastered status across a variety of skills, looks a lot like your current profile of mastered versus unmastered skills. So we can find these individuals who looked like that at some point in their career and then have achieved later on some goal state that is similar to the goal state that you are interested in as an individual. So just as a simple example, let's say you're currently at the point in your career where you've earned a PhD in cognitive science, you're proficient in coding, and you've completed coursework in machine learning. So you will have a very unique, you know, profile of mastered versus unmastered skills, and someone else who was similarly at that place earlier in their career may have at that point a snapshot of mastered versus unmastered skills that looks like your current one. And let's say they went on to become a data scientist. We can then use data from the pathway they took and successfully reach that goal to help recommend pathways for you to then go on to do to get there. Okay, so another class of modeling that I think shows a lot of promise for intelligent pathway recommendations is Markov decision processes. So Markov decision processes are a class of models that help you decide how to pick a next step action given the current state that you're in. And it has some good features that I think make it applicable to intelligent pathways. It has the ability to maximize decisions based on not just short-term reward states, but also the trade-off between long-term desirable outcomes and short-term rewards. It also accommodates uncertainty quite well, and also a variant called partially observable Markov decision processes can accommodate our ability to estimate, what state you're in along this pathway without maybe full observational data or full information about that. So the very basic way that an MDP, Markov decision process, works is that there are states that you can be in. So this is a very simple example just to kind of give you an idea of what these elements of the model are. So this example is that you're running a startup company and your goal is basically to become rich and famous, or I guess basically just to become rich. So your initial state is poor and unknown, and you have two different actions you can choose to do at any state, which is to either save money or advertise. And so in this case, the states in the model are poor and unknown, poor and famous, rich and unknown, rich and famous. You can imagine that in a real, career pathway recommender, there would be way, way, way more states than this. But this is just an example to illustrate it. And and you would also have many more choices for actions as well. So there's these different actions. And and then there's also reward functions that define sort of the long-term versus the short-term reward trade-off of different kinds of actions in terms of what state they move you to. And then there are also probabilistic state transition functions, which basically give you the probability that you're going to move from one state into a different state, given that you choose a certain action. That's the basic way that works. And the main goal is to learn what we call a policy that will approximately maximize a long-term expected reward. And that can be defined differently in different models, which would allow us to have different models for different general goals and be able to have different policies depending on what your goal is. So the idea would be that in an intelligent pathway recommender, your state would be captured by these S nodes here. And you can think of it as something like a collection or basically a snapshot of what skills you actually have at that point in time. So each variant of that or common variant of that could be considered a state. And so the goal is to basically learn the model from a ton of longitudinal and variable pathway data, and then use those learned models to plan policies for different kinds of goals, and then use those to make recommendations for an individual depending on what state they're in. All right, so finally, I just want to wrap up by highlighting some of the really exciting research that's happening surrounding intelligent mentoring systems. So this is the program. I'm going to kind of show you some different parts of the full program for this workshop called Intelligent Mentoring Systems that had its third annual meeting at this year's Festival of Learning in London. So some of the themes that we can see in this workshop include self-regulated and lifelong learning. So this is really cool. We see some, and I'm going to actually dig in a little more detail to the Clara the counselor model. But we also have things like how can we better support self-regulated learning? So this is self-regulated learning is a great sort of topic that encapsulates a variety of 21st century skills. And it's really promising that people are focusing on this in research because, it's going to help our students be able to continue to teach themselves to adapt with the changing economy. And I've included the URL here, and I can share it afterwards as well, so that you're able to go take a look at any of these papers you might be interested in. So another part of the workshop was STEM and computational thinking. This has been very popular among the same kinds of schools and programs that have been promoting 21st century skills. So the idea is that we are becoming a tech world, and it's becoming more and more important to be able to, even if you can't code, to be able to think computationally so that you can understand the way that, code works and how it's affecting our world. That's great. And then lots of research on affect. This is a slightly older area of research, but it's still very relevant for estimating things like, what is a student's motivation? What really excites them about learning, and what doesn't? These are all really relevant to forming a more complete profile of someone's whole personality characteristics. Okay, so I'm just going to show you this quick example of one of the projects that was featured in this workshop. This is the Claire the Counselor system design. This was designed to help the Navy navigate their personalized career needs. And you can see that some of the themes that I highlighted throughout this webinar are showing up here. So, here in the upper left corner, you can see that one of the big pieces of their model is integrating all of these sources of data, K-12, annual evaluations, on-the-job experience and performance, ASVAB, like all of these things into a store that can connect them properly, right? A sailor's knowledge, skills, abilities, and competencies. And then we've got things like, what the sailor is interested in, or what, what they want their goals to be. And then we've got basically the skills that are required, the job requirements of the Navy. And so all of these different things get integrated, right? So here's the data coming in, and we're matching that up to, what are the requirements of the Navy. And the one element that they emphasize here that I didn't talk about, one of the elements that they emphasize here that I didn't talk about much today, but that's a really interesting area for future research, is this kind of actual agent who is going to provide engaging and interactive career guidance. So for us, we don't really have an agent that does this. We really like to have the human agents, who are the counselors, the teachers, the parents, be the people to kind of take the information about skill gaps and help a student then, go out and facilitate that skill gap closing process. But yeah, this is a very interesting piece that, might have robot counselors. I'm not sure. I'm not sure if we want that, but it's certainly something that some areas of research are looking at. Okay, so just to quickly summarize, I talked about an approach which involves adapting mastery-based personalized learning from its traditional use in academic areas to more job and career relevant skills. And this involves the same process of identifying those target career skills, measuring and estimating the individual's mastery levels of those through various ways, either using surveys or questionnaires, or lots of multimodal classroom data collection, or using the data that we already get from schools and from education technologies. And then identifying the gaps that stand between an individual and their goals, and then recommending out really good and well-validated resources that will help them fill those gaps. And then I also talked about some ideas for intelligent pathway recommenders. Once we have, we're at a place where we have a lot of rich and diverse longitudinal data that we can use to basically, the idea would be to use the experiences that other people have gone through to help an individual who's earlier on in a particular career path to navigate that and know what sequencing might be helpful for them. All right, so that's it. Thank you for listening, and I'll take any questions you have now.
Thank you. And why don't you, so if you have questions, type them in the Zoom chat window. I will monitor those and relay them to Ron. So Ron, I have one question about your approach to intelligent pathway recommendation and using POMDPs for that, which is how do you incorporate user choice and preferences into that framework? What if this POMDP says, oh, you should work on this on math, and the student says, I don't want to work on math? Then how is that resolved?
That's a really good question. I think that one thing we could do is provide the information to the student to say, this is, this is what the optimal policy recommends, but here are some other good actions, and here are kind of this is the relative trade-off of these actions. So we could actually provide more of what the model is telling us as information to the student and still allow them that choice ultimately, right? And it's really meant at the end of the day to be a recommendation based on what previous people have experienced, but in no way is any part of the process supposed to mandate anything for a learner. I know that within some academic subject-specific tutors that use that, they do actually mandate something in a way because they just select the next item for the student.
Right.
But I think that when we're talking about something larger scale, like choices of what to do next to further your career, we just simply can't do that, right? It has to be a suggestion. But I think that we can provide some of that information, and we can provide it in an interpretable way if possible. That's the challenge always, is like turning the policy into something that's interpretable to a human. But if we can explain to them, like, well, this is why we recommend this, people who did this ended up then doing this and this, and then they achieved this at this age or at this point in their career, and just kind of giving them that information, and they can make up their minds themselves. I think that would also be a valid way to use that.
Okay. And a related question, what age range do you envision this sort of mentoring system be useful for? Like, would elementary school students use this?
That's a good question. I would say that from our experience, it's from the school's perspective, they're most interested in it for high schoolers and somewhat middle schools as well. I think that in the elementary school age range, I think the focus probably ought to be more on career exploration rather than actually providing very strong suggestions. I think that it's nice to give information to students, allow them to actually, even at the middle and high school levels, right? They're still very young, very early in their careers. Their careers will probably take very winding paths in all reality. And so I think that the goal is more to use these kinds of tools to allow them to rapidly be able to say, hey, I just kind of want to know how I measure up, to a marine biologist. Because I'm kind of interested in it, or I watched a movie and I'm kind of wondering, what it would take. And so just to kind of allow them to explore those things in an informed way, and then allow those students who really have strong passions to be able to have the understanding of how to achieve their goals, and just have nothing standing between them and the goals, even if, they don't have all of the resources within their school or within, just their home life.
So there's a question from Julia Carney. Can you talk about the similarities or differences between closing skill gaps for students versus professionals, people in the workforce?
Yes. So I think that one of the big differences is in the kinds of resources that you would provide. So closing skill gaps for students is going to involve a lot more, I guess, school decision constrained things. And so basically, the idea is that schools decide what kinds of resources they want to pay for their students, that they're interested in for their students, and teachers have a lot of opinions on that too. So, the kinds of places like, ST Math or iReady or Carnegie Learning that you might go to for a student, it's just going to be somewhat constrained by the choice of those stakeholders. And then you have things like Khan Academy, In the workforce, I think there's actually a lot more, at least how it stands now, there's a lot more focus on soft skills, and many employers have their own programs that they like to use for improving things like this. And so I think it's just a matter of very different resources. But I think that, our goal is to, and, the skill profiles will be kind of different, but the goal is really, to come up with a good system, which, is well characterized by this mastery-based personalized learning system that you can use in schools or in the workplace just the same. And so just to come up with that generalized way to, at any point in life, you have this goal state, and then you have, this measurement of where you are, and to be able to identify what you need to work on. So I think the overall architecture is very similar.
So part of what you're doing is, reminds me of some of the work that LinkedIn has been doing of analyzing job openings and analyzing skills of workers to see where the gaps are. And looking at what you're doing, and especially using your natural language processing techniques, I'm wondering if you have been gaining some special insights about where the skill gaps are and the nature of those skills in the workforce. Anything that you'd like to share?
Yeah, so I would say that the biggest difference is that LinkedIn really relies on a self-reported version of, where you stand along a wide variety of skills. And our goal, and we're still in the early stages of this, but our goal is to go deeper than that, to actually get validated measures of these skills, and especially in the version of the skills that's actually, that this particular employer cares about. So there's different flavors of problem solving, and technical problem solving might be really important for a particular job, but just because you're able to do a non-technical problem solving in a school project may not be relevant, right? So part of the very ambitious goal is to actually, understand from validated measurements, as well as, context-specific observational data, to be able to get a rich picture of where you actually stand on these skills, and not just rely on someone to report that they have 5 or 6 of these skills needed. And I think that that's a limitation that is difficult to get around for good reason, but that's the goal, to eventually work on that. And so we've started working a lot in the educational domain because the measurement devices are much better defined, but now we're kind of moving into this world of how do we better measure these 21st century skills? And that's where the research community is going to be really critical, because, it's starting to develop these really new methods, new ways of making sense of data. And I think there's a lot of potential there, but we're definitely, I think, as a field, in early stages of being able to do that. That's the goal.
A theme that has come up in a number of our webinars is the potential of AI to empower teachers rather than replace them. And I'm wondering what your thoughts are about this type of intelligent mentoring system as being something that can assist and empower other human mentors and counselors.
It's a great question. I think that, one of the best ways to empower teachers and counselors, for example, is to provide them with an easy to digest way to view the data, and to view, what any of our models can infer about the data. And so, with traditional academic assessments, they get reports that have scores and all that stuff. But what I think a good intelligent mentoring system can do that's analogous to that is actually provide, data visualizations, provide, summary reports to teachers that really give them information about the student at a whole person level. So, going way beyond just their academic skills, giving them an idea of why might this student be struggling? Is it because of you know, they're just missing a lot of school? Is it because they're lacking motivation? Why might they be lacking motivation? So these are some of the kinds of qualities that we're hoping to be able to get at to then provide that full picture to the people who are so important to educating these kids.
As you probably know, a common use of AI these days in educational systems is predictive analytics to identify learners who may be having difficulty or could be predicted to have difficulty in the future. And I'm wondering what you see as the role of predictive analytics in the context of what you're doing here.
Okay, so there are schools who are interested in understanding, you know, is this particular student going to pass their standardized exam? And they're interested in bringing not just the academic data into that prediction, but all of the data that exists. So there's that aspect, and you know, we do have the ability to do that given the data that exists, and I think that, you know, I think it's a challenging question, because I think it can be very helpful to schools to identify, you know, individuals that are at risk for something like that, or something broader, like they're at risk of not graduating high school, for example. But I also think that we have to be careful, because you don't want to have, you know, this is a kind of general problem in the ethics of data science, which is that you can end up more strongly stereotyping what's going on. So if you really classify someone as like, oh, they have an extremely low chance of graduating high school, or an extremely low chance of passing, you know, this and that, then I actually think that it could lead to them getting less attention in some cases than those who are more, you know, on the cusp. And so I just think that it's really important for us to be careful about, you know, how all this data is getting used, even in a predictive analytics fashion. But I do think that we will be able to predict things a lot more accurately with a whole person data, as opposed to just, you know, purely academic data.
So relating to that, what do you see as the issues relating to control and ownership of one's data, and making sure that it's not being used in ways that you don't want it to be used?
Mm-hmm. So I think that it's a very important issue, and it's a tough issue. But I think that, you know, there's varying levels of kind of guarding data from, you know, being tossed around in ways that or going places, or being used in ways that it shouldn't be. One is the sort of permission at the level of the school or the level of the employer, who have some ownership over that data. Another is at the level of the different ed tech stakeholders who produce that data. So, you know, typically if you access it, you have to sign very detailed data agreements, and there's you know, some protection in there for where that data goes. And then I think that ultimately, you know, the data, especially for us, you know, when students become adults and they have, you know, access to perhaps longitudinal K-12 data, you know, they have the right to take a copy of that with them and control how that's being used, and who they provide that to, and which pieces of data they provide that to. At least our philosophy is to do that, to give that power to the individual. And the hope is that, you know, when they offer up their data, it's providing some greater benefit back to them that is going to help them. And I think some of that responsibility lies in the companies and the researchers who are accessing that data, you know, to be focused on, you know, the benefit that they can provide back to the individual, and not just, you know, whatever they want to do with the data other than that. So.
Great. So any other questions from the participants before we sign off? Okay, I think we're good. Well, thank you, Ron. That was an excellent talk. I think people enjoyed it. And best of success with your efforts going forward.
Thank you very much.
So as a reminder to everybody, next week our webinar will be by Kurt Van Lane. and he's going to be talking about intelligent orchestration systems, how systems can help orchestrate different learning activities within a learning context, and how can technology help that. I think it should be a very interesting presentation, and I encourage you to sign up for it. So that's it for today. Thank you, Ron. Thank you, all the participants.